Classful network is a network addressing architecture used in the Internet from 1981 until the introduction of Classless Inter-Domain Routing in 1993. The method divides the address space for Internet Protocol version 4 into 5 address classes. Each class, coded in the first 4 bits of the address, defines either a different network size, that is number of hosts for unicast addresses, or a multicast network. The 5th class address range is reserved for future or experimental purposes. Since its discontinuation, remnants of Classful network concepts remain in practice only in limited scope in the default configuration parameters of some network software and hardware components. Background: originally, a 32-bit IPv4 address was logically subdivided into the network number field, the most significant 8 bits of an address, which specified the particular network a host was attached to, and the local address, also called REST field, which uniquely identifies a host connected to that network. This format was sufficient at a time when only a few large networks existed, such as the ARPANET, which was assigned the network number 10, and before the wide proliferation of local area networks. As a consequence of this architecture, the address space supported only a low number of independent networks, and it became clear very early on that this would not be enough. Introduction of address classes, expansion of the network had to ensure compatibility with the existing address space and the Internet Protocol packet structure, and avoid the renumbering of the existing networks. The solution was to expand the definition of the network number field to include more bits, allowing more networks to be designated, each potentially having fewer hosts. Since all existing network numbers at the time were smaller than 64, they had only used the 6 least significant bits of the network number field. Thus it was possible to use the most significant bits of an address to introduce a set of address classes while preserving the existing network numbers in the first of these classes. The new addressing architecture was introduced by RFC 791 in 1981 as a part of the specification of the Internet Protocol. It divided the address space into primarily 3 address formats, henceforth called address classes, and left a 4th range reserved to be defined later. The first class, designated as Class A, contained all addresses in which the most significant bit is 0. The network number for this class is given by the next 7 bits, therefore accommodating 128 networks in total, including the 0 network, and including the existing IP networks already allocated. A Class B network was a network in which all addresses had the 2 most significant bits set to 1 and 0. For these networks, the network address was given by the next 14 bits of the address, thus leaving 16 bits for numbering host on a network for a total of 65,536 addresses per network. Class C was defined with a 3 higher-order bits set to 1, 1, and 0, and designating the next 21 bits to number the networks, leaving each network with 256 local addresses. The leading bit sequence 111 designated an escape to extended addressing mode, and was later subdivided as Class D for multicast addressing, while leaving as reserved for future use the 1111 block designated as Class E. This addressing scheme is illustrated in the following table. The number of addresses usable for addressing specific hosts in each network is always 2n, 2 where n is the number of REST field bits, and the subtraction of 2 adjusts for the use of the all bits 0 host portion for network address and the all bits 1 host portion as a broadcast address. Thus, for a Class C address with 8 bits available in the host field, the number of hosts is 254. Today, IP addresses are associated with a subnet mask. This was not required in a Classful network because the mask was implicitly derived from the IP address itself. Any network device would inspect the first few bits of the IP address to determine the class of the address. Bitwise representation: in the following table, N indicates a bit used for the network ID. H indicates a bit used for the host ID. X indicates a bit without a specified purpose. Class A, 0. 0. 0. 0 equals 0.00000.00000.00000.00000.00000.00000.00000. 127.255.255.255 equals 0111111111111111111111111 0 NNNNNNNN H Class B 128 0 0 0 equals 10,000,000.0000000.0000000.0000000 191.255.255.255 equals 10,111,111,111,111,111,111,111,111,111,111,111,111 10 NNNNNNNNNNNNNNNNNNNN Class C 192 0 0 0 equals 11,000,000.0000000.0000000.0000000 223.255.255.255 equals 11,000,111,111,111,111,111,111,111,111,111,111 110 NNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNN Class D 224 0 0 0 equals 11,100,000.0000000.0000000.0000000.0000000 239.255.255.255 equals 11,101,111.11,111,111,111,111.11,111,111 1110 x x x x x x x x x x x x x x x x x x x x x XXX Class E 240 0 0 0 equals 11,110,000.0000000.0000000.0000000.0000000 255.255.255.255 equals 11,111,111,111,111,111,111,111,111,111,111 1111 x x x x x x x x x x x x x x x x x x x XXXXXXXXXXXXX Replacement of classes. The first architecture change extended the addressing capability in the Internet, but did not prevent IP address exhaustion. The problem was that many sites needed larger address blocks than a Class C network provided, and therefore they received a Class B block, which was in most cases much larger than required. In the rapid growth of the Internet, the pool of unassigned Class B addresses was rapidly being depleted. Classful networking was replaced by classless inter-domain routing, starting in 1993 with the specification of RFC 1518 and RFC 1519, to attempt to solve this problem. Before the introduction of address classes, the only address blocks available were what later became known as Class A networks. As a result, some organizations involved in the early development of the Internet received address space allocations far larger than they would ever need. See also, IPv4 subnetting reference, classless inter-domain routing, list of assigned /8 IPv4 address blocks, subnetwork, private network, common use of classful networks, references. External links, IANA, current IPv4/8 delegations, overview of IP addressing, both classless and classful.